This is your teacher Jenny. Join me for another topic. This time, we're going to talk about writing standard equation of a hyperbola using the distance and the midpoint formula. Okay, let's start with the first given. So this time we are given with the center at 2, 2, vertex 1 at 0, 2, and focus 2 at 5, 2. So without graphing this one, we can actually use the midpoint or the distance formula to get all the information that we need so that we can write our standard equation. So first, let us try to do the orientation. So the orientation, we can just simply spot it using the vertex information and so with the focus. So if you try to look at this, we've got a vertex at 0, 2, focus 2 at 5, 2. They have the same value on the y. So since they have the same value on the y, that means to say that our vertex and the focus is moving on the horizontal direction. And because our x changes on the value of our vertex 1 and focus 2, so that means to say that this is horizontal. So basically, if you have the same value on a particular coordinate or component of the coordinate, then that means to say that the orientation will be of those that are with the different values on that particular component, just like this one. Now let's go to our A. Now our A is the distance from the center to a vertex. Now since we are given the center and the vertex, we can simply look at this. If you try to look at the y values, they are the same. So we go for those that are different in values. So we have the center and then the center and the x value of the center, and so with the first vertex x value, we are going to utilize that one to get our A. So how to get A? Now, since A is a distance, so since they have the same value on y for the center and the vertex, we don't bother using that one, because again, once you use that one in our distance formula, if you try to have recall the distance formula, you've got that one as the square root of your x sub 2 minus x sub 1 squared, and then plus your y sub 2 minus y sub 1 squared. So that is our distance formula. So if you happen to have the same value of your y's, so this is basically gonna be 0. That means nothing. And this will result to like this. X sub 2 minus x sub 1 squared. So basically we're canceling the square root and the squared here. So that is why we've got x sub 2 minus x sub 1, which are the different values on that particular component. So what I'm trying to say here is to avoid a longer way in getting the distance, since most of the values here in our hyperbola, we will be dealing with one component which has similar in value. So that is why you just have to go directly to those that are different in values and then subtract that one to get the distance. So we have here A is equal to, we can start with the bigger value of x, which is 2, and then subtract that one with a smaller value so that you will have a positive result. Because if you try to switch that one, you will be getting a negative result. And if that happens, you may drop that one, because when we say distance, everybody, that's an absolute value, meaning to say it's gonna be a positive value. So we have here A is equal to 2. Now since we have A, so we can have our A squared, which is equal to 4. Next one, we need our B, but since we are given with our F sub 2, our focus, we cannot find directly our B. We are going to go through with C. Now C here is the distance from the center to a focus. So we have here center at 2, 2, focus at 5, 2. We have the same value on y as well. So again, once we are getting the distance, we just have to subtract those that are of different values. So we have our x values on center and the focus. So we start with a bigger one. So we have 5 as the x value of the focus minus our 2, which is the x value of the center. and c here is equal to 3. It follows that our c squared is equal to 9. We can now look for our b squared. So to solve for b squared, we can use c squared equal to a squared plus b squared. And since we're looking for b squared, we can move our a squared to the other side so that we can have c squared minus a squared equal to b squared. Arranging or swapping those places, we can have it as b squared equal to c squared minus a squared. And plugging in, we've got b squared is equal to, our c squared is 9, minus our a squared, which is 4. Our b squared is equal to 5. So since we have b squared, that's 5. Our b here is square root of 5. Okay, so we are now ready to write our standard equation because we have now the center, the orientation, our a squared, and our b squared. So let's now write. Our orientation is horizontal, so basically we'll start with an x minus h squared over a squared minus y minus k squared over b squared, that's equal to 1. So plugging in, we have x minus our h is, here from the center, we have h and k. So we have x minus 2 on h squared over our a squared, which is equal to 4. And then minus y minus k is 2 squared over b squared, which is 5. That's equal to 1. So this is now the standard equation of our hyperbola. Okay, let's go to the second example. We have the given information such as our focus 1 is at negative 2, negative 3. Focus 2 is at negative 2, 3. And transverse axis of length 4. So, first, we are going to get the center because we don't have the center here. But we can generate the center because we are given with a foci. So, the middle point of the foci is going to be the center. So we will be using the midpoint formula. Now since we have the same value on x, so instead of us doing a longer way for us to do the midpoint formula, we just have to simply copy the common value or the same value on one coordinate to the other. So we have here same value on x, so we just copy that one here on the center x value. And then on the y value, we just have to simply add this 2 here. So you just add that 1, negative 3 plus 3, and then divide that 1 by 2. Or simply getting the middle value of that y. So this is now 0 over 2, which is equal to 0. So we have negative 2, 0 as our center. So we have now the orientation. Now, based on the foci here, we have the same value on the x. So that means to say that our orientation of the hyperbola is vertical. Because if you try to look at that, our focus travels vertically because our value on y changes from negative 3 to positive 3. So that is vertical. And then we are going to look for a. Our a here, according to the given, we have the transverse axis of length 4. Now, since the transverse axis, that is equivalent to our 2a. 2a, as the given here, we have 4. To get our a, we just have to divide that by 2. Our a here is equal to 2. So, a is 2. Our a squared is 4. Now, on B, we cannot look for B directly, so we can simply look for C because we have the given information and the focus, and then the center. So we are now going to get the distance from the center to a focus or vice versa. So if you try to look at this, we have the same value on X. So again, we are going to use those that are different in value. So we start with the bigger one, which is 0. Followed by minus, and then the negative 3 as the y value on our focus 1. You can actually use focus 2 y value. That's really fine. You'll still get the same answer. So C here is equal to 0 minus negative 3. That is equal to 3. Our C squared here is 9. Now, to solve for our B squared, we can make use of our formula a while ago. We have B squared is equal to C squared minus A squared. Plugging in, we have C squared, which is 9, minus our A squared, which is 4. So our B squared is 5. So we have here B squared is 5. Our B is square root of 5. So out from this information, we've got the center, the orientation, and then we've got A squared, B squared. We can now write our standard equation of the hyperbola. So we start with, since that is vertical, we start with y minus k squared over a squared minus x minus h squared over b squared. That's equal to 1. Then plug in, we have y minus, our center here is negative 2. We have h on that one and k as 0. So y minus 0 squared over a squared, which is 4, minus x minus our h is negative 2, and then squared over b squared, which is 5. That's equal to 1. So simplifying that one, we have y minus 0, that is y squared over 4 minus x minus negative 2, that would lead to x plus 2 squared over 5, that's equal to 1. So that is now the standard equation of the hyperbola. Let us now go to our another example. We have here the given is at a center, which is an origin, vertices at 0, negative 5, and 0, 5. And length of the conjugate axis is 4. So let's start with our orientation, because we have now the center is at origin. So orientation based on the vertices, we have the same value on x. So our different values are on y, so that should be vertical. And then we have A. A is the distance from the center to a vertex. So since we have the center at origin, which is a 0, 0, and then we have also the vertices, we can choose 0, negative 5, in which our x values are the same. So we will be subtracting or making use of the y values, which are different. So we start with the bigger one, which is the 0, minus our negative 5 on the vertex. And then A here will be equal to positive 5. So our A squared here is 25. Next, we are now going to look for B. Our B here is going to be generated out from the length of the conjugate axis. Because when you say length of the conjugate axis, that is 2b, in which that is equal to 4 on this problem. Once you wanted to get b, you just have to divide out 1, and our b is equal to 2. So we have now b equal to 2. Our b squared is 4. We have now the orientation, the center, the a squared, and the b squared. We are now ready to write our standard equation. So we start with, since that is vertical, we have y minus k squared over a squared minus x minus h squared over b squared equal to 1. And then we have here, plugging in y minus our k for the center. We have that as 0, so y minus 0 squared over our a squared, which is 25, minus x minus h, which is 0, and then squared over b squared, which is 4, that's equal to 1. So simplifying that one, we have that as y squared, because y minus 0 is y, over 25 minus x minus 0 is x, and then we square over 4 equal to 1. So this is now the standard equation of the hyperbola. So again, please practice more so that you will be able to really master the skill for this particular lesson. So once again, this is your teacher Jenny saying good luck.